Selamat sejahtera and hi, my name is Junlin Jaji. I'm going to explain the theory of this experiment. In order to understand this experiment, at first we need to know the working principle of pitot tube. Pitot tube is a device that can be used to measure the velocity of a flowing fluid. First of all, I need you to imagine that this is a moving fluid. Now, consider a piezometer tube. A piezometer tube can be used to calculate the static pressure of the moving fluid. Next, consider a pitot tube. The column height of the fluid inside the pitot tube will be higher than the piezometer tube, and this extra height is called dynamic pressure. When a water particle enters the pitot tube, its velocity will convert to dynamic pressure, and stagnation pressure, which in our lab sheet is called total pressure, is the total sum of static pressure and dynamic pressure. The stagnation pressure represents the pressure at a point where the fluid has brought to a complete stop. Now let us apply the Bernoulli equation and derive the formula for the stagnation pressure. For that, let us write the flowing water as 0.1 and the head of the pitot tube as 0.2. The velocity at 0.2 is 0, and the height of Z1 and Z2 is 0. After solving and rearrange the equation, we will get that the stagnation pressure is the sum of static pressure and dynamic pressure. Now we can measure the velocity of the moving water, V, if we know the dynamic pressure, and it can be easily calculated by measuring the pressure head. The next thing we need to know is the behavior of pressure and velocity in the converging and diverging section. In a normal situation, when a fluid goes through a converging section, its pressure decreases while the velocity increases. In contrast, when a fluid goes through a diverging section, its pressure increases while its velocity decreases. Now let's apply the theory I just mentioned in the experiment. This is a pitot tube, and the air is coming from here, flowing into the pitot tube. This part of the pipe where the air flows directly into it is used to measure the total pressure, and it is connected to H1. While this part of the pipe is used to measure the static pressure, and it is connected to H2. By having H1 and H2, we can calculate the total pressure and static pressure with this formula, where the capital P represents the total pressure or stagnation pressure, and the small letter p represents the static pressure. And with this formula, which I just derived from Bernoulli equation in the first slide, we can calculate the velocity of the flow using total pressure and static pressure. This equation is as same as this, just in different arrangement. Finally, with the pitot tube and Bernoulli equation, we can obtain the pressure and velocity of air flows through a converging and diverging section. And according to the theory, when a fluid goes through a converging section, its pressure decreases while its velocity increases. So when the x distance, which is the vertical height of the converging and diverging section, increase, the pressure will decrease while the velocity increase. And for the diverging section, we are unable to test it in the experiment due to the head of the pitot tube being unable to reach there. But according to the theory, when the fluid flows from here to here, the pressure of the fluid will increase while the velocity will decrease. For your information, the pressure mentioned here, which is changing along the converging and diverging section, is the static pressure. For the total pressure, it will be constant along the converging and diverging section according to the Bernoulli equation. To sum it all up, we have three objectives in this experiment, which is first, to determine the distribution of total pressure and static pressure along the converging and diverging section. Second, to determine the change of air velocity along the converging and diverging section. Third, to compare this with the prediction of Bernoulli equation. That's all from me. I'll pass it to my groupmate. Thank you.
Assalamualaikum and hello, my name is HAMZAH LUQMAN bin ROSDI, number matrix AA200168. Okay, so before we start our experiment, let me explain to you how this machine operates. We will use this flow bench apparatus to conduct our experiment. Okay, after we turn on this machine, the blower will generate air and the pump will push up the air to the nozzle. Then, the air will flow out from the nozzle and enter the diverging and converging section machine in a clear acrylic and finally reach the outlet. The air is then flown into a pitot tube that measures the static and the total pressure distribution along the converging and diverging section. Both of the tubes are connected to the multi-tube manometer to obtain the data of static pressure and the total pressure. So, the tube H1 is for the total pressure and the tube H2 is for the static pressure. So now, let us start the experiment. Step 1. We open the main switch and also the VFD. Step 2. We press the start button to open the blower. Step 3. We set vertical distance Y of converging and diverging section to 30 mm. Step 4. We observe the pressure reading H1 and H2 from the multi-tube manometer and record them into the table. Step 5. We repeat step 3 and 4 by adjusting the distance Y with 60, 90, 120, 150, 190 and 210 mm. Step 6. We turn off the blower by pressing the stop button. Step 7. We turn off the VFD and the main switch. And so, we are done for this experiment.
Hello, my name is Chan Junwei. Now I will show how to calculate static pressure, total pressure and air velocity from the data recorded from the experiment. In this case, we take 30 mm for our sample calculation. When x is 30 mm, we get H1 for 90 mm, which is 0.09 meter, and we get H2 for 0.115 meter, and we know that the density of air is 1.22 kg per meter cubic. So to calculate the pressure, we must know the general equation for pressure, which is P equals to rho GH. Now let's start with the calculation of total pressure. So look at the yellow color mark. So we get H1 is 0.09 meter, which is here, right? As the datum is at this location and the height we need to find is here. So as we know, the total height for this manometer is 0.3 meter. To find this height is very simple, which is 0.3 minus our H1, which is 0.09. So we can calculate the total pressure now. So P equals to rho of the air times with the gravitational acceleration and the height, which is 0.3 meter minus H1. And we can get an answer which is 2.513 Newton per meter square. So same goes with static pressure. We know that our H2 we get in this experiment is here, 0.115 meter, and the height we need to find the pressure from the datum is here. So we just use 0.3 minus H2 we get, which is this. So we can also find the static pressure with this equation. And we get 2.214 Newton per meter square for our static pressure. And now we can finally find the air velocity. So the air velocity is given as formula like this: V equals to root of 2 capital letter P minus small letter p over rho. So just substitute all the value we get. So we can get a final answer as 0.700 meter per second.
Hello, my name is Tang. I will continue presenting about graph for this experiment. For graph of static pressure, total pressure versus distance, when the distance increases, the static pressure decreases. It means that the static pressure decreases with increase of altitude. Furthermore, the static pressure is always lower than total pressure, as the total pressure is a sum of the static pressure, the dynamic pressure, and the gravitational potential energy per unit volume. For graph of velocity versus distance, when the distance increases, the static pressure decreases. When the static pressure decreases, the velocity increases. The increased velocity means the flow has more kinetic energy. The energy has to come from somewhere, so the pressure has to drop to match that energy change. That's all for our group. Thank you.